welcome back to another Code With Me tutorial. Today is going to be a little bit different in that we are going to be exploring my library. So what I'm going to do is I'm just going to go through, set it up at the same time, and yeah, we're going to look at all the advantages of my library, including the config creator, mechanism drivers, loop time controller, scribe, servo plus, PID motors, and a bunch of other things. So I'm just going to go through and set this up real quick. So what we're going to need to do first is in the Gentrified Apps util library, look for installation instructions, and boom, there it is. In build.gradle file in team code. So we're going to go Gradle scripts, find build.gradle in team code right there. And then all we need to add is our little comment right here, the implementation. And we can see that the newest version right here is going to be 4.8.2. So we replace a version. We'll let me replace it. 4.8.2. And then in build dependencies Gradle, now we need to add another repository. So we'll grab the Maven. Just copy that and paste it right there. And now in build common Gradle, we're just going to add this to the packaging options. So we'll scroll down. There's our packaging options. Grab only the excludes, and there we go. All right, now what we're gonna do is we're gonna hit this nice little button right here that says sync now, and what it's gonna do is it's gonna show us, hey, we're actually building the files now. So yeah, we just need to wait for this to work. And one of the nice things we can do here is we can find download info, which is going to tell us what's actually happening. So it found the files and it's able to download them. So we should be good anytime now once it finishes downloading everything. So we have all the files now. And depending on how fast your computer is, how fast your Wi-Fi is, it'll go differently. So, it'll just be what it is and call it a day. So one of the cool things that I want to show you today is let's just make a base subsystem. And I'm going to show you the power of what we did earlier with classes. And we're just going to go extends subsystem. And you can see that right here, it's packaged inside of the Gentrified Apps util library. We do that, and now we have errors. So now all you have to do is you have to hit implement methods, hit OK, and boom, it's all right here. So as you know from before, what we could do is all we need to do is we just need to add content of these functions. So in ARM subsystem, we would add this to our initializer, and then in here, we would call init, and then update is the same, telemetry is the same. When you call base subsystem, it will be exactly the same. Really, you don't have to do anything else. We'll create this constructor and then just go init. And that's literally all you have to do. And now you have your full subsystem architecture. So this is one of those ways where it makes it a little bit easier to have an architecture and actually show you what's going on. And it's also just a base. So you can do anything you want with this. Creates it for you with all the big methods that you need. So that should be pretty easy. Next up, we'll go config creator. So I'm actually going to have to open up this to actually show it to you. Now I'm going to search it up. We're just going to search up config creator, and here it is. So normally with a config, what you have to do is you have to go into the Android Studio, or not Android Studio, you have to go into the FTC robot controller on the driver station, and you have to configure it, and you have to do all this stuff, and it's terrible to do on the actual device. However, what we can do is we'll just open this link up. Oh wow, we have a config generator. I'm going to call this pinkbot because that's the name I use for everything. And we'll just call servo, and that is going to be in port 1. We'll add that device, and now we go, okay, we want a motor. Let's see, it's going to... So my recording just paused and didn't tell me, but we add that device and then we hit generate data. When you hit generate data, it will automatically start a download. Download it to the correct directory for your project, and then we can look in here, config registrar, right here. We're all good to go there. All you have to do is set the package name, and that's about it right there. You can add many more things just by dot, and then let's say we want to add camera. Let's just add a camera named camera. And the thing with the camera is you have to have a serial number, so it's going to be like X1029 or 1027 or something like that. So you will have to scan the devices to find what camera you have, anything like that. You'll figure it out as you go and as you get more advanced. But basically what this is going to do is it's going to add a op mode called config creator to your list of all of your configs or all of your op modes. You run it, and then you go to the config button and set it as active, and that's all you have to do. So it makes it super easy. You can see that we have a bunch of types here. Obviously I'm not going to read all these out to you, but this is all the stuff you can add to it, and that's about it. So that makes it super easy because you can generate on the fly and you have a saved copy of your config no matter what, because it'll always regenerate it the same. As long as you don't change stuff in here, it'll always regenerate it. Super easy to use, super quick to set up, and it will save you time in the long run. Alright, and next up, we're going to rewrite our hardware config. So what we're going to do here is we know we have all these different motors. So what we're going to do is we're just going to go up here, and you'll see why. We're just going to go driver and take this one right here from Gentrified Apps Util is equal to null, and we'll just call it drive for right now. Now I'm just going to put this below. We're going to go drive equal to driver, and then we're just going to add the new in the front, and then we're going to look at the parameters. So we can have a linear op mode, we can have string, direction. So I'm going to go with that one. And it's going to take it in order of front left through back right. And then we go, okay, what are our directions? And we'll just add, what are our directions? Forward, reverse, forward, reverse. Alright, and you can see that once it's done with that, it's going to populate this and say, okay, what's our back right name, back left, front right, front left. So there we go there, and add a semicolon at the end. And now we'll just go drive dot. Ooh, what is the function? I should look at the actual code for this, because I don't 100% remember how I did this. We can also do things like drive mechanism, which I'll show in just a second. Let's check what our driver looks like. Okay, I might be teaching you wrong here. That's so fun. So I'm just gonna look into this real quick, and let's see. We have methods in here. We have a show encoder positions. We'll also have to add an op mode to initialize it. Okay, there we go. That makes more sense now. So let's just add op mode to the front of this, and then it'll automatically do all the initialization stuff for you, so we can delete all of this, and that's all gone. We can delete all the DC motor stuff, and now we can just have a driver. So what we'll do next is we'll also just replace this, because we can just say drive mechanism, and we might have to do more things with this to actually get it to work. But we'll call mechanism driver dot drive mechanism, and then we're going to put in our float x, float y, and float rotation. So as you can see right here, we have x, y, and rotation. So we'll just say op mode dot gamepad1 dot left stick x, comma, negative op mode dot gamepad1 dot left stick y, and then op mode dot gamepad1 dot right stick x. So now what drive mechanism is going to do is it's going to give us a value of drive power coefficient. So we say drive power coefficients, powers, is equal to that. And basically what that's going to do is it's going to give us a list of front left, front right, back left, back right. Now what we'll do is we'll say drive dot, and then let's see, I forgot how to do this because I haven't done this in a very long time. Oh, set wheel power to powers. And that's it. So we've condensed all of these lines right here into 2. So that's one of the big advantages, because it makes it really easy for us to actually do the coding and make it look really nice, make it look really simple. People can understand it because it just works. I will add this to the bottom because typically you don't want to set a power up here, because if we say something like, oh yeah, I want to change the power, well, it's not actually going to apply until the next cycle. So even though the cycle is going to be really short, we still don't want to do that just for productivity reasons. So always power at the very end. Next, what we're going to do is we're going to implement the loop time controller. So I'm going to go back to here, and we're going to just go loop time. And we can see there's a lot of stuff in here. I want the actual loop time controller though. Okay, yeah, so it's an effective way to help you monitor how fast your robot's updating. You can read through all this on your own, but we're just going to look at how to use it. So what we'll do is we'll just add the loop time controller. So loop time controller, I'm just going to call it LTC is equal to null. Actually, I don't think we have to do that. We can call it here. We do not need to actually wait for it to be initialized like we do with most of the rest of this stuff. So if we do that, we can see it takes nothing. It takes no parameters. We don't even need an elapsed time. Literally just call loop time controller. And then in here, we can find out what it does. So we'll call it LTC, and we can see that we have minimal telemetry, we have a loop saving cache, we have a reset. So right in here, we'll reset it. And here we'll call LTC.telemetry with our telemetry object. And down in here, we'll call LTC.update. So you can see this is structured very, very, very similarly to how we would structure a subsystem. And I do that intentionally so you can actually use it. But now, I mean, if you want to, you can use the minimal telemetry right here. You can use the loop saving cache. Basically what that does is it's just another measure to help save some loops, get you some of your RAM back. So now we'll go into scribe. So this one's really fun because I can go scribe.getInstance. And then all we need to do, I'm just gonna say start logger with op mode. And what this is gonna do is it's just gonna print out, hey, this is what's happening in the system. We're just gonna log, hey, we're started. And this is the op mode we're started on. So as you can see on this left side, we have a log cap right here. So obviously I have nothing connected, but you can go tag colon and then scribe. And what it's going to do is it's going to show you all of the things you logged to scribe right in here. And you can see what was going on with your robot at any time. You can also pull these logs using the Rev hardware client and then search for scribe throughout there. Super simple, super easy. So next, what we can do here is we can just say scribe dot get instance dot log data, and we'll just say arm powered do 1.0, and now that's just gonna log it to the data set. So there's a lot you can do here, including catching errors and telling your user, in this case, what the error was. Really beneficial to track what actually happened in your program, because most of the time it's just stuff just happens and you don't know why it happened, so how are you going to be able to fix it? So now we have a way to fix it. Next up, we're going to look at Servo Plus. So I'm just going to scroll through here real quick and find out where Servo Plus is. There we go. Okay, so we got a Servo Plus, and it's an extension of the Servo class. So we set to a correct degree instead of the 0 to 1. So now let's go in here, and we didn't have a Servo before, but let's just add a Servo Plus. I'm just going to add S plus equal to null because we can't initialize it yet. And then in here, we'll just go S plus is equal to Servo Plus of hardware map and then the name. And that's all we need. If your servo is different or it's acting up, you can put in a degree, which will just adjust it slightly to fit your servo. So now what we'll do is in here, we can also just say, okay, yeah, if this happened, we'll just go S plus dot set position, and then we'll just go 90 degrees because that's where it's going to be set to. If we look through here, we can see that we also have all the functions given by the regular servos. So we have all these set directions, but it works exactly the same as the actual servo class. It just adds degree usage here. So next, let's go through a PID motor real quick. So basically the whole premise behind a PID motor is to package, and I'll just write this out real quick. We're going to package the PID controller and motor, and just use them together. So we can just say PID motor, P motor equal null, and then we'll just go down here right after Servo Plus and just go P motor is equal to that. Super simple, super easy way to set it up. You can initialize it with a PID and F. You can initialize it with a direction. And I'll include the link to this entire util library. But if we look at this, PID motor dot, and I'll just explain what some of these do. So if we say current reversed, basically what we're saying here is, hey, our encoder ticks aren't going the way we think they should be. Let's reverse it. Reset, we're just going to set everything back to 0. Super simple there. Normal functions over here for all of this. And then we have our set PIDFs. And then we can also set it to a PIDF coefficient or the PIDNF. If we say set PID power, what it will do is it's going to automatically calculate it for you, given your PIDF values and where the current position is. So that's the plus there, because we don't have to do all 90 lines of calculation or anything like that. We don't have to use any extra classes. We just say, okay, pmotor.set PIDF, give it a PIDF, which, I mean, I'm just going to put in zeros, and then pmotor.set PID power. And that's literally it. You just put in 2 lines. So that'll make it super simple, super quick for you to add a PID to your system. Makes it more readable and a lot less lines. So that's the plus there. And again, I will link this entire util library, but as you can see, there's quite a bit more, even just than that. There's a bunch of stuff in here. So use it. It has voltage compensation, movement controllers, all that kind of stuff. So please let me know if you have questions as well, because this is something I made, but yeah, it makes it way easier and way simpler to understand. So that'll be it for this video.